suppose we have this region. This is O, X, Y. And we would like to integrate a function f over this region. So what we will do, we will divide it into message. Okay, this is dx, this is dx, and this is dy, and there is a function f here. So this is how much? fxy dx dy, and this value is, let x value is a here and x value is b here, y is c and y is d. So this is x equal to a to x equal to b, y equal to c to y equal to d. This is the double integration. This is what the double integration. In the double integration, what is also there, if you change, if the limits are, note one thing, if the limits are constants, very important point, if the limits are constants, then integral a to b, integral c to d, d by dx equal to c to d a to b fxy dx dy. Note this point. But this is in case when your integral is rectangular, means have constants limit. In this case we use this. Okay, only in case of constant. Please note down it. Okay, this apply only in case of a constant, not for all. All right. Can you see this example 1.2? What type of R here? You can see this is your x equal to 0 here. This is x equal to 2, x equal to 2. And this is y equal to 1, and this is y equal to 4. This is y equal to 4, and this is y equal to 1. This is x equal to 0, and this is x equal to 2. When we say x equal to 0, it means y axis. When we say y equal to 0 means x axis. Okay. Hello. Hello. Yes, thank you. Thank you very much. So this is the R. Which region is R? This is R. This one. This is R. This is R. Okay. And DA. This is how much DA? This is how much DA? And please note it, DA equal to dx dy or DA equal to d by dx. Okay. DA equal to, DA means the area of a small element. For example, this is the small element. So if this is dy and this is dx, so area of this element is how much? DA. You know, area of a rectangle is how much? Suppose this is your rectangle. This is dy, this is dx. So area of this rectangle is how much? DA. DA means length into width. Length is how much? Dx. Width is suppose dy. So DA is how much? Dx dy. Okay. Bandar, is still how many are absent? Bandar? I think 4 are absent still. Suleiman joined. Saleh, Suleiman, Omar, Omar Al Omar. Suleiman here. Okay. Omar is here. Okay. Okay. Okay, Omar. This is the element, area of element dA equal to dx dy. And where is Muhammad Al Dhafari? Muhammad Al Dhafari. Not here. And we want to find this area. Saleh have a problem. Ask him to check with this link. Oh, so bad. So can we switch to Zoom? Zoom. Hello. Yeah, Blackboard is better. This is better. Yeah, please ask him to check again. Okay. D equal to dx dy and d equal to d by dx. This is like in the multiplication. This is like in the multiplication. So this is the dA. dA means the area of a small element, and we call this mass. What we called it? Mass. This is small element, you know, this red one you can see in the graph. This red one is the mass. So we divided the whole region into masses, into several masses, right? So this is our interest, to find the double integral. So it's very simple. Look at here. We are writing here 6x square plus 4xy cube dx dy. Now we need the limit for x. Okay, x is which direction? X. This is the direction of x, and this is the direction of y. This is for x and this is for y. We would like to integrate it. So what you need to do, this element, how much you can take to this side? Up to this boundary, up to y-axis, right? Hello? You can take this element up to where? Up to here. And when you push to the right side, when you push this element to the right side maximum, you can go to this boundary, right? Right or wrong? So the limits of x are from where to where? 0 to 2. 0 to 2. Okay? To find the limit for x, we will take the element left and right. We will take it up to left. Okay? And for the limit for y, we will take up and down. Up and down for the limit for y, and for limit of x, we will take it right, left, left to right. The limit is start from left to right. And for the y limit, it starts from down to up, down tahat to fog. Okay? And for the limit for the x, isar to yamin, left to right, left to right. The limit for x is from left to right, and the limit for y is from up to down. So at the left side, how much is the x? How much is the x at the left? 0. And at the right, this is 2. So the limit is 0 to 2. And for y, this is our y. You can see this. We need the limit for y. So y limit we can obtain by, now it is form of a strip like this. Okay? This strip you can take up to down, up to what? Up to this boundary. and upside we can take this strip up to here, and here y is 4 and here y is 0. So the limit for y is how much? 0 to 4. Sorry, here y is 1, not 0. Y equal to 1 to 4. Okay. So when your limits are constant, you can see these limits are constants, not moving. Your limits are constants. When your limits are constant, not to worry anything, just apply the limits, nothing else. When limits are constant, see the just plug in the value, directly apply the limits without thinking anything. Okay, these are the simplest questions in the multiple integration. Okay, can we move to next? So your integration is now like this: 6x square plus 4xy cube dx dy, and x limit is 0 to 2 and y limit is 1 to 4. Okay, so you will say this is a limit for x. We integrate as per these integral sign. Okay, we start from here. This is 1, this is 2. Okay, we start from here. So you can see these limits are for x. These limits are there for x. So we will integrate first with respect to x. Okay. After integrating with respect to x, we will apply the limit for x. Then your integrate is free from x after applying the limit for x. Okay, so you have the whole picture like in terms of y. Look at picture how we need. We are integrating first with respect to which variable? Which variable? Hello. We are here integrating with respect to which variable first? X. We are integrating here with respect to x, because our inner integral is having a limit for x, so we will integrate with respect to x first with respect to this. Okay, so 1 to 4. One thing is to keep in mind, while we integrate with respect to x, when we integrate with respect to x, we treat y as a constant. Okay, we just integrate with respect to x, then we treat y as a constant. And when we integrate with respect to y, we treat x as a constant. Whatever the x function, that is the constant. So this is the x function of y function. This one. This is this one. This is the x function or y function. Who is right and y? You can see directly that it involves x only. So this is the x function. Omar, from where you are seeing that this is y? Omar, this is y function or x function? Omar, I take something new. I'm talking about this. Now I'm talking about it. This is y function or x function? Mashallah, mashallah. Still you are learning that this is x function. Now this is y here. I'm talking about red. Red one. I mark red sign. I'm talking about that. Very good, mashallah. Mashallah, very Umar. Umar, this is x or y? Umar? Oh, good. Very good. We are ready with this too. X, good. So you know this formula, integration of x to the power n is how much? With respect to x. Okay, this is here x square. Tell me the integration of x square how much? This is x cube over 1, right? So the integration of this is 6 into x cube upon 3 plus what is the integration of x? X square upon 2. Omar, you are telling x plus 1? Omar, this is x square upon 2. So here this value is how much? X only. What is this? X. So its integration is 4 into x square upon 2 y cube, and the limit is from where 0 to 2 dy. Is it visible to all? Muhammad al-Fadi. Muhammad just log in and go for sleep. Muhammad Abdullah and Al-Fadi. Muhammad. No. This is one Muhammad al-Fadi or Muhammad Abdullah. I'm not talking about at that time. I'm just kidding. You're not happy to hear Muhammad. Whatever happened? Everything is fine. Muhammad. Mama C. No, don't say like this. Look at here. This is 3. This is 6. 3 to 6. Okay, Mama. 6 upon 1 is how much? 2. 6 upon 1 is how much? 2. And this is 4. And this is 4. And this is 2. So 4 upon 2. Again, how much? 2. So this value is 124 2x cubed plus 2x square y cubed limit 0 to 2 dy. Okay, our lecture will be 12 up to 12 o'clock day. I'm not going to leave you before 12 o'clock. One to four. What is the upper limit here? What is the upper limit? This is the upper limit, right? And this is the lower limit. So this is 2. So plug in this value wherever it is x. X is here and here, right? Muhammad. This is x. So just plug in here the upper limit. Okay. So this is 2 cube plus 2 into 2 square y cube minus. What is the lower limit? 0. So wherever is x, plug in this lower limit. 2 times of 0 cube plus 2 times of 0 square y cube. In this board there is a problem, means erase, you cannot erase the selected item. You have to erase the full. This is the problem in this. So this is 1.4. 2 into 2 cube, how much? What is the value of cube? 2 cube. 2 to the power 3. How much is it? Muhammad of the ferry. Muhammad. Where is Muhammad? Khalid, this is clear. Khalid. Okay. 2 cube is 8 into 60. And this is 8 y cube dy. Okay. Now it's now simple integration. Can you solve it? Okay, please solve it within a minute. You have done it time. How much is your answer? $126. Really? 526. Ali. See here. 124. We will integrate directly. 16y plus 8y to the power 4 upon 4 limit 1 to 4. Okay. Now apply the limits. What is your limit here? Hello friends. My kids, my son. What is the limit here? This is 1, this is 4, right? Apply the limit. So this is 16 times 4 plus 2 times 4 to the power 4 minus 16 times 1 minus plus 2 into 1 to the power 4. Okay. 16 into 4. 64 and 4 to the power 4 is 286. Right? 286 into 2. 512 minus 16 minus 2. Okay. So 512 plus 64 or 48. How much is this solver? 64 plus 512 minus 18. So 46 plus 558. This is 558. I might know. Yes. 558. Ali, you are doing mistake. For a simple question, your answer is 526. Why? Ali, focus. You are not concentrating. Okay. Understand or not? Let's see some questions. Okay. We will try some questions. Can you see the screen? Hello guys. Hello. Which question let's try? Five. Okay, very good. 5 and 7. Okay. This is question number 5. I'd like to ask one thing, if you don't mind. Where is again Muhammad? Muhammad, Muhammad, are you here? Muhammad. Okay, focus. Okay. Very good question. What do you want here? What do you want? Volume. Volume equal to simply or you can see in all questions what are the limits. This is over the rectangular region. Rectangular region means this is this. This is 1. This is 4. Sorry, 0 to 3. Look. This is here. And the rectangular lines are from where? This is x equal to 0. And one more line. Let's say x equal to 3. This is x equal to 3. And this is y equal to 1. And this is y equal to 4. So this is the region. This is the region. Can you see the region? Hello. Okay. If you take some element like this, This is your element. Okay. This is your element. Now we need the volume. We are trying 5 number. Okay. Which question we are trying here? 5 numbers. Good. So I will see the response also. This is visible. This is hello. Okay. We are trying this approach. You want to apply this or this? One or two? Z d by dx or z dx by one. Okay. So volume v equal to z dx by. What is the value of z? This is x square plus y square dx dy. Okay. Now we need the limit for x here and the limit for here for y. If you write like this, then this is outer, inner. Okay. So we need the limit for x. The limit for x. So you can, this is your element. You can take this element up to this boundary maximum and here up to this boundary. So here x is how much? Here x is this side x is and here this side x is 0. So this is x equal to 3. So the limit for x are from 0 to 3. And the limit for y 1 to 4. Simple. Now it's very simple. We will integrate this as to x first. What is the integration of x square? That is x cube upon 3 plus xy square limit 0 to 3 dy. Okay. Okay or not okay? Now apply the limit. 1 to 4. Upper limit is how much? 3. So we will plug in 3. 3 cube upon 3 plus 3 y square minus what is the lower limit? 0. So 0 cube upon 3 plus 0 y square dy. Write the problem. Okay. So this value is total. Zero. So this is 1 to 4. 3 means 27 upon 3. So this is 9 plus d by square dy. Okay. Okay or not okay? What is this integration? This is 9y equals to 3y cube upon 3 limit 1 to 4. 3 cancel. So now apply the upper limit 9 into 4 plus 4 cube minus 9 into 1 plus 1 cube. 9 into 4 is 36. 4 cube is 64 minus 9 minus 1. So this is 36 plus 64, how much? 100. 100 minus 10. So this is it. 990. Okay. Umar why is Saleh accepted? Understand? Understand it? You want to write down question? Would you like? Would you like to write down question? Okay, see one question. Which question you want from these 5 we have done already? Which question you want? Okay. Do say one. Go for 7. I'm giving you 5 minutes. Okay, try for 7. You are for 5 minutes. Done. Answer is 7. The 7 number requires some complicated integrals, integration by part. It's however it's simple, but it requires integration by parts. You want to see it now? 7. Hello. Okay. Okay, I'm solving it. Just remember the function. This is z equal to x e to the power x plus 2y sin y. This is how much z equal to 6 plus x e to the power x plus 2y sin y. And the limits for x and y, 0 is less than x less than equal to 2 and 1 is less than equal to y less than 4. What are the limits? Yes, 1 to 4, 0 to 2. Alright, this is your question. This is question number 7. What do you mean? This is the volume over R. Here R is how much? 0 is less than x less than equal to 2, 1 is less than equal to y less than equal to 4. Okay? Is that clear, mister? Z is 6 plus x e to the power x plus 2y sin y dx dy. Okay, the limit for x. What is the limit for x? The limit for x is 0 to x. Oh, sorry, 0 to 2. And the limit for y? 1 to 4. Good. Now we will integrate first. This is the limit for x and this is the limit for y. Now we will integrate it. 1 to 4. The integration with respect to x, how much for this? 6x, right? This is how much? What is the integration of 6? 6x. And you know, here, this is x and this is e to the power x. So this is what? This is the product of two functions. This is the product of two functions, right? So let this is first function and second function. First is x, second is e to the power x. So we will differentiate this side. This side, what we will do? We will differentiate. And this side, what we will do? We will integrate. What is the derivative of x? 1. And integration of e to the power x, e to the power x. Derivative of 1, 0. Integration of e to the power x, right? And we will stop here. Now this is multiply here with plus sign. We will multiply here with minus sign. Okay? So how much you get? This is x e to the power x minus e to the power x. The integration of this is how much? X e to the power x minus e to the power x. And you can see this, this is what? This is a constant with respect to x. It's a constant with respect to x. Right? Right or wrong? So its integration is how much? 2y sin y, and this is like x. So its integration is 2y sin x, 2y sin y times of x, and the limit is 0 to 2 dy. Is that clear for all? This is the integration of x e to the power x. This one, the down. Okay? Omar, very good. You are following full time today. The limit for, these are the limit for x and these are the limit for y. Now we will apply them. So, okay. So this is 1 to 4. And here, this is your x, this is your x, this is your x, this is your x, this is your x. So wherever is x, we will put 2. We will put 2. Okay? So how much we will get? This is x. So in place of x, how much we will put? 2. So this is 6 times of 2 plus 2 e to the power 2 minus e to the power 2 plus 2y sin y into 2 minus wherever is Now the lower limit is 0. So wherever is x, b will put 0. So 6 into 0 plus 0 e to the power 0 minus e to the power 0 plus 2y sin y into 0 and here dy. I'm sorry, here this is can you see this? What is this written? If you cannot, I will delete it and rewrite. This is dy. Okay. Now, who will tell me 6 into 2? How much is 6 into 2? 12 plus. This is 2e square and this is minus e square. So 2e square minus e square, how much? 2e square minus e square, how much? This is e square. This is 2, this is 2. So 2 into 2, 2 into 2, 4. 4y sin y minus 6 into 0, 6 into 0, 0. 0 into this, 0. And e to the power 0, e to the power 0, how much? E to the power 0, 1. So this is minus 1 and 2y sin by 0 into 0, this is 0. So this is minus 1 only and here is dy. Okay. Now see 1 to 4, 12. This is minus minus, this is minus, this is minus. So both minus, this is minus, this is minus. So both minus become plus. So 12 plus 1, 12 plus 1, 13 plus e square plus 4y sin y and here dy. Okay? Okay or not okay? Very good. Very good. Now we need to integrate with respect to y. So it's simple. You know integration of this is how much? This is 13y. 13y. All right. 13y. Okay. Plus e square y. And here, how you will integrate this? This is y sin y. This is y sin y. This is the product of two functions. This is how much? Product of two functions. Yeah, by part. Great. So this is first y, second sin y. So this is differentiation of y. This is d. This is I, integration. This is d derivative and this is integration. So derivative of y is how much? 1. And integration of sin y? Integration of sin y? Minus cosine y or cosine y? Hello? Integration of sin y is how much? Omar? Omar? What is the integration of sin y? Okay. So this is cosine y. Okay? And derivative of 1? Derivative of 1? 0. And integration of minus cosine y? Minus sin y. Clear? So we will multiply this here with plus sign. Don't miss. Our class is up to 12 o'clock. Are you ready for it? No? Okay. This is y into minus cosine y. How much? This is minus y cosine y and plus sine y. Limit 1 to okay. This is okay. Now apply the limit. Now we will apply the limits. What is the upper limit here? 4. Okay. What is the upper limit here? So this is 13 into 4 plus e square into 4 minus 4 cosine y plus sine 4 and minus lower limit 13 into 1 plus e square into 1 minus 1 cosine 1 plus sine 1. Okay. So very simple now. 13 into 4. 13 into 4. 13 into 4, 65. 13 into 4, how much? 52. So this is 52 plus 4e square minus 4 cos y. Why y here? Put here 4. Plug in here 4. Y here y. It should be 4. Okay. So 4 cos 4 plus sin 4 minus 13 minus e square plus cosine 1 plus sin 1. So 52 minus 13, this is 39 plus 3 square minus 4 cos 4 plus sin 4 plus cosine 1 plus sin 1. Okay? Understand? Everyone understand? Bandar. Mr. Bandar. This is okay. Before you, what is the name? Turkey? What is this name? Abdullah. This is okay, Ibrahim. Who is Ibrahim in our class? I have never seen him. You calculated with the calculator? Okay, now you understand this. Now we will go for the integrations which have the boundary. Okay, airports guy, always wear the airports. Okay. Abdul Malik. Daily I read you Abdullah because the last word I read it and before that Ibrahim. Good morning, Ibrahim. Ibrahim, good morning. How are you? Do you understand it? Do you understand? I'm also good. Thank you for asking. So today we covered the double integration in case when limits are rectangular region. Now we will go for another situation when in which the region is what type? What type of region? The moving boundaries. The moving boundaries. The boundaries are like this. Can you see this? Region R. In previously your region R was type. the dark shaded region in this figure, you can see the limits are, these limits are what type of these the limits. You can see this. I have to change the color. This, can you see these limits? These are changing, not fixed like this. Here, for example, this is the fixed limit, but here you can see for different value of x you have different y. Here you have some different value of x, here you have different y, right? So this is not a fixed boundary. The boundary is not fixed, that is variable. The boundaries are not constant. Then how we will deal with the problem? This is the volume over a, when boundaries are not constant. Only the problem with the limits. When we apply the limits, then we get some difficulty. But no problem, we can do it. Don't worry. So come to this. Can you note down this? Here. This figure and this. Note it. Done? Now see this question. Very important. You have to be focused here for a few minutes, okay? Are you ready for focusing? Is it fine next class? Who is writing this? This is Omar. Omar, you want next class? And what about others? All wish to in the next class or now?